Can entropy decrease in any irreversible process in physics? Have you ever wondered if it is possible for entropy to decrease during an irreversible process? This question is fascinating and dives deep into the heart of thermodynamics. Let's break it down together. First off, entropy is a measure of disorder or randomness in a system. According to the second law of thermodynamics, the total entropy of an isolated system can either increase or remain constant, but it can never decrease. This means that in any irreversible process, the total entropy always increases. Think about it this way. When you pour cream into coffee, the cream mixes and creates a more disordered state. That mixing process is irreversible, and it leads to an increase in entropy. The natural tendency is for systems to move toward greater disorder. Now, let's look at what happens during irreversible processes. These include things like heat flowing from a hot object to a cold one or the mixing of different substances. In these cases, the energy becomes more dispersed and less available to do work. This is why we see an increase in entropy. In some situations, you might notice that the entropy of a specific system seems to decrease. For example, when ice melts in a warm drink, the entropy of the ice itself decreases. However, this local decrease is always outweighed by a larger increase in the surroundings. The total entropy change, which includes both the system and its surroundings, is always positive. This principle is why energy transformations are never 100% efficient. When energy is converted from one form to another, some of it is always lost as unusable heat, contributing to an overall increase in entropy. To sum it up, while local decreases in entropy can occur, they are always accompanied by larger increases elsewhere. The total entropy of an isolated system will never decrease during irreversible processes. This fundamental principle helps us understand why certain processes happen spontaneously and why systems tend to evolve toward greater disorder over time. So, the answer to our question is clear. Entropy cannot decrease in any irreversible process in physics. It's a fascinating concept that highlights the natural flow of energy and disorder in our universe.